Hey folks, so today I want to talk about my Cobra 29 project radio here. So there's a lot of stuff going on in here, and later on in this video I'm going to pop open the lid and show you what's inside. But first I want to talk about what's going on, why I did what I did, and show you some of the effects on the scope, and show you what happens when we plug in a linear. So basically this is a modulated radio. For those of you that don't know what the modulator is, it's a modulation circuit that allows you to do some unique things with a fairly standard radio. So one of the first things that you can do is you can adjust the dead key up and down, and you can adjust what's called asymmetry. So I'll show that here in a moment. Let's see, what do we got going on here? Okay, so this radio is set up to use a stock mic. So this microphone goes in. It goes in through the standard mic port, but it doesn't go through any of the standard audio processing that's built into the radio. So the entire audio processing circuit and modulation circuit are completely custom. There's that whole part of the circuitry is not even really connected to the stock audio circuit inside of this radio. Now, basically the first thing that happens when it goes in here, it goes through a preamp. So the preamp amplifies the signal up to a level that we can work with. And then it goes through a bandpass filter. Now the bandpass filter is something I designed and soldered together myself. It cuts off around 100 hertz up to, I think it was around 6,000 or 7,000 hertz is kind of when the frequency really starts to roll off. So after it goes through a bandpass circuit, it then goes through a limiter. So there's a diode limiter in there that keeps the peaks from exceeding a certain point. And then after it goes through the limiter, it goes through another amplifier that brings the signal back up after limiting. And at that point, it goes into the modulator circuit. So there's a reason that I did all of that. And it's kind of hard to explain. It's probably a lot easier to show. Okay, so I've got my modulator controls on the front of the radio here. This one is asymmetry, so I'm going to turn that all the way down. This one is dead key, carrier level. RF gain is still RF gain. Dynamic is still mic gain. So let me see what we can do here. Okay, let me turn the scope up a little bit so we can see what we're working with. Let's try that. Let's get in there. Crank it up a little bit more so we can really see it. A little bit more. There we go. So we've got our carrier level at about 2 boxes. So a standard AM modulation would double that in voltage. So we would go, sorry for the contrast here, you can't really see the boxes. And a standard AM would go from 1 box to 2 boxes. But the asymmetry control allows us to go a little bit further. So let me adjust my mic gain. 1, 2. Crank that up a little bit. Let's try right there. Audio 1, 2. Check, 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 check. Audio test. Woo. Okay. So that's a pretty standard AM modulation right there. Audio. So the peaks are about twice as high as the carrier level. So the peaks that we're seeing are a little bit shy of twice as tall. Audio. Now watch what happens when we turn up the asymmetry. Audio. You notice the peaks are extruding much higher than they were before. And that's exactly what the modulator is there to do. So it allows us to take those positive peaks and raise them up a little bit. Now there's a few benefits to this. One of them is that as your positive peaks get louder, as your positive peaks go higher, your audio becomes louder in the receiving radio. It's crazy how it works like that, but it really does work like that. So let me see if I can demonstrate that. All right, so over here, I guess I gotta change the channel. Let's go up to 27. Okay. So we got this radio monitoring. I'm going to put the cell phone up to the headphones so you can hear the audio that's actually coming out of the radio. So the first one I'm going to do is no asymmetry. So audio. Okay, we're going to listen to that one first. Audio, 1, 2, check, 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 check. Okay, now I'm going to turn up the asymmetry. Audio, check, 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 test, test, 1, 2. Okay, that was with the asymmetry. Let me turn it back down. Audio, check, 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 1, 2. So hopefully that came through on the phone. Hopefully you can hear the difference in sound there. So that's one of the first benefits to running some asymmetry. Now you can achieve that by clipping the limiter in a radio. So if this was just a stock Cobra 29, I could go in there and snip the limiter or adjust the AMC pot and get a similar improvement in loudness. However, by clipping the limiter, we lose our negative peaks. Audio. So if you notice, audio, that's with asymmetry. So you notice the carrier is not pinching off. It's always got a little bit of carrier left. So let me I'm going to turn down the asymmetry and pretend like we clipped the limiter. Audio. So that's what you get when you clip the limiter. Audio. If you notice, the carrier's cutting off really badly. And, it actually, on the receiving radio, that doesn't sound too horrible, but it splatters all over the band. Pinching off the carrier like that creates lots of spurious emissions. So that's the whole point of the modulator, is you can push the asymmetry up without damaging your audio by pinching it off, without creating spurious emissions by pinching it off. And that's why I built this radio. And I wanted it to be for a stock mic so that I could have it in the mobile without having a whole bunch of goofy gear attached. That's why I built the audio filtration circuit and a few other things. But before we talk about that, let's talk about what the asymmetry can do for you if you run a linear. So let me turn this on here and see if we can monitor this on the scope. I'm gonna have to crank that down quite a bit. Okay, let me adjust my knobs here and make sure I'm all in order. Alright. Okay, that's a pretty good carrier level. Let me adjust that down a little bit. Okay, right about there looks correct. Alright, so I'm going to show you. Hopefully you can see the boxes in the scope. If not, I guess it is what it is. But let me demonstrate what happens when you run no asymmetry into an amplifier. Audio, audio. I don't know if you can see that, but with just the radio, the peaks were extruding right about to twice the carrier in voltage. With the amplifier, the peaks are extruding a little bit less. So we lost some of our peaks by running it into an amplifier. So that happens because all amplifiers suffer from an effect called compression. So let's say you put 1 watt into your amplifier and you get 100 watts out. Okay, that's all fine and good. But if we put 2 watts into our amplifier, we should get 200, right? Yes, we should, but we don't. That's because of compression. As you raise the power up, it takes more power to get the same proportion of power. So what's happening is our carrier, let's just say for example, our carrier's at 1 watt and we're getting a 100 watt carrier out of the amplifier. Well, if our peaks are at 4 watts, then our peak should be at 400 watts, but they're not. They're actually in the neighborhood of 300 watts. That's not exactly true for this amp, but that's a very good example of what we're experiencing here. And unfortunately, all amplifiers suffer from that effect, and it gets worse and worse as you try to push more power out of them. So this being a quote-unquote 500 watt amplifier, if we run it at a 25 watt carrier, with, what would that be, 100 watts PEP, we're not going to see much compression. If we put 1 watt in, get 25 watts out, we put 4 watts in, we're going to get very close to 100 watts out. But as you start pushing the limit of the amplifier, that compression becomes a much bigger effect. So, let's talk about what we've got here. This is a Texas Star 500V. I think it's all in good working order. It seems to be doing its job. I can't quite drive it hard enough to get every last drop out of it, but I'm going to try and demonstrate what we got going on here. Okay, so first thing we're going to do is we're going to adjust our carrier level to where we want it. So if this is a 500 watt amplifier, we want our carrier to be about a quarter of that or less. So no more than a quarter of the maximum output of the amplifier. So let's just go with 100 watts. So 100 watts is technically 1/5 of the amplifier's maximum output. Okay, so right about there, we've got our amplifier putting out a 100 watt carrier. Now let's see what happens when we don't drive any asymmetry into the system. So hopefully you can see the divisions on the scope. I'm having a really tough time because the sun's in the eye. Okay, there we go. Audio. Audio. So if you notice, our positive peaks are only going about from here to here. So if our carrier level is right here, our positive peaks are only going here. So what that means is we're only getting about 300 watts PEP out of this amp when we should be getting 400 or even 500. That's compression, and that's why your audio sounds like crap, because the amplifier kind of limits your positive peaks. So if you remember earlier what I was saying, the higher the peaks, the louder you're going to be in the receiving radio. So by driving this radio into an amplifier, we're getting a better signal on the receiving radio, but our audio is quieter. Now, I don't know what you guys think, but I think that's a problem. So that's the whole point of asymmetry. Let's see what we can do here. Let me crank up this asymmetry control and see if we can improve the matter. Let me go back to the scope real quick. Show you one more time. Audio. Okay, so make note of where our positive peaks were. Now let's crank up the asymmetry. Audio. So if you notice, there's a significant improvement there. We got a little bit more excursion on the positive peaks. Now, unfortunately, this amplifier suffers from a lot of compression. We're definitely driving it into a range that only so much can fix it. But let's go a little bit higher on the asymmetry and see what we get. Audio. So we're still not at 100% modulation. We're still not there. I'm driving, let's just say this carrier is probably about 2 watts and my PEP is probably about 16 watts. So we're driving that ratio into the amp, which is probably like what is that? That's a 1:8 ratio of carrier to PEP we're driving into the amplifier, but we're not even getting 1:4 out. Compression, it sucks. So if I were to use this radio with this amplifier and I wanted it to be loud, one option is to turn down the carrier, but keep my PEP about the same. So let's try that. Let's adjust our carrier down to, say, 75 watts and see what we can get. Okay. So that was about 70 watts. Now let me readjust my oscilloscope so that we're at our reference point. Okay, so let's give this another try. This is no asymmetry. Audio. Need to turn down my mic gain. Audio. Okay, we're no longer pinching off the carrier. Maybe a little. Are we pinching off the carrier? Audio. Test, 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 test. So if you can see, just by driving the amp a little bit less, our positive peaks actually came out a little bit relative to the carrier. So now let's try putting a little bit of asymmetry into the system. Here's our carrier. Audio, audio, 1 2 1 2 1 2. Check, 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 check. Finally, we have accomplished 100% modulation, maybe a little bit more. So it's actually really hard for me to see the screen, so I imagine it's hard for you guys to see the lines on there, but that looked like it was over 100% modulation to me. So that's actually going to be louder in the receiving radio than the previous setup was. It's going to be louder. It's less power, it's less carrier power, but it's going to be louder. It's hard to explain. I'm not a receiver expert, so I can't tell you why the receiver perceives that as being louder, but it does. It's a real thing, and that's why people cut their limiters, to get that asymmetry. But the thing about the modulator is you don't have to suffer the negative effects of cutting the limiter, but you still get the positive effects. So that's why this radio exists in my lab. But I forgot to mention, really sorry for the messy desk, but that's just how I am, man. Once I get started on a project, I don't clean up a damn thing until it's done. And this has been a long project. There's been like 3 or 4 different projects that have come across my desk in between, and oh yeah, it's the disaster zone over here. But anyway, I hope that explained a few things. I hope you learned something, and I hope you become conscious of the effects of compression in the amplifier, because it'll really screw you up. You got a nice loud radio, you think you're kicking ass, but you set your carrier level too high, and all of a sudden your audio level is way down. Nobody can, you're quiet, and that'll do it right there. If you want to be loud and proud, you got to turn down your carrier, and you got to up your PEP. So that's how you get a decent sound. That's how you get a little bit louder. Of course, the shape of the audio waveform is a whole nother topic of discussion, and that plays a big part in how loud you are. But just in general, asymmetry makes you louder. Bottom line. It's a very good thing. There's a lot of things you can do to the shape of the audio to improve your loudness as well. You know what? Let me see if I can demonstrate that. So I mentioned earlier that there is a limiter in this radio. And what that does is it kind of flat tops any peaks that extrude beyond a certain point. So let me I think I can leave everything right where it's at. Okay, so let me turn off the asymmetry, and we'll just look at the shape of the audio waveform. Audio, 1 2, audio. Okay, so if you notice that, everything was very smooth, and it followed the sound of my voice very accurately. There was very little distortion in there. Now that's because I was talking quietly into the microphone, and I wasn't hitting the limiter. So when I start to hit the limiter, the positive peaks of my audio are going to get rounded off and somewhat clipped. So the louder I get, the worse the clipping is going to get. The way I design the limiter, it's sort of a soft clipping, but it is still a form of clipping. It's just not sharp, unless you speak really loudly. If you yell into the microphone, it will clip sharply. But watch the audio waveform as I start to speak louder into the microphone. Audio, 1 2. Audio, 1 2. Audio. So if you notice, we went from nice smooth sine waves, and we started clipping more and more, and slowly became a square wave. So a lot of the loud radios you hear out there are very clipped. They're clipped badly like that, and they're pinched off at the carrier. And when you pinch off at the carrier, that creates all kind of harmonics, and it definitely changes the quality of the audio. Some would say it's better, some would say it's worse. It's up to you. But that's just one example of how to manipulate your audio to be louder. By clipping off the audio like that, I think that we actually get a little bit of a bump in average power. So people say bird watts. I'm going to turn off the amplifier. My radio is at 0 asymmetry. So this is no asymmetry, just however it comes out of the radio. So let's see if we have forward swing here. Audio, audio. All right, that's forward swing. So if I talk quietly into the microphone, you notice I'm not getting much forward swing. I'm getting a significant amount of modulation. I'm getting full modulation, 100% modulation or close to it, but I'm not getting any forward swing. And that's because of the shape of my audio waveform. So as I start talking louder and start clipping the audio, I'm creating more average power. Audio, audio. By changing the shape of the audio waveform, I can create more average power. And that's what they call bird watts. You know, there's the eternal argument between, oh, PEP and bird watts. Both of them matter. All watts matter, okay? So the first thing is PEP. Having a high PEP to carrier ratio will make you louder. Now, there's a limit to that, obviously. If you go like a 1 watt dead key and you're swinging to 100 watts, it's not going to help you. But if you're at a 1:4 ratio, 1 watt carrier to 4 watt PEP, as you go up from that point, you're going to get louder up until the cutoff point kind of varies by receiver. But if you have 200% modulation, for example, so if you have a 1 watt dead key and an 8 watt swing, you know, you're probably not going to hear much of a difference between that and like a 1 watt dead key and a 6 watt carrier. But once you get over the 1:4, that's when you really start making a little bit more noise in the receiver. So that's one aspect to consider. The second aspect to consider is the shape of the audio waveform. As you can see, when you compress and limit the audio waveform, you start to see more average power coming out as you modulate. So there's a lot of stuff that you can play with to get louder. And it's really a trial and error thing, and it really depends on the receiver that's listening to you. It's a complicated subject. You can spend hours on hours, you know, with your headphones on, listening to your receiving radio, tweaking your settings, trying to get your audio just right. And as soon as you power this up and put it into somebody else's receiver, it might sound a little bit different. So anyway, this is my Cobra 29 project. This has been going so long, I don't think I'm going to tear this down in this video, but, you know, it's not too exciting. It's just a bunch of freaking circuit boards that are all smashed together in there. And if you're wondering about the Panasonic speaker, I needed room for my circuit board, so I had to pull the internal speaker out. And I mounted this one to the bottom. This one's going to go in my mobile. For the record, these speakers sound 2,000 times better than the stock speaker in this radio. You can actually hear people out of this speaker while you're driving down the road with the windows open, and it's got bass, it's got mid-range, and you know, you got something like this little Midland sucker right here I use just for testing stuff. It sounds terrible. This thing is all treble, it makes no bass, it sounds horrible. It actually sounds worse than the stock speaker on the Cobra. But having one of these little Goodwill, you know, center channel thrift store finds, it's an improvement. Like, I did this for you, mud ducks, so I can hear you. You know, you can fix your radio, but you can't fix other people's radio. With a better speaker, you can fix other people's radio. They will sound better. But anyway, rant over. I hope you learned something from the video. I hope you enjoyed staring at my messy desk. And this is Mud Duck Sharky, and I'll be back with another video one of these days.